So my name is Manjeet. I work as a business intelligence engineer in Amazon. So my work involves like creating large ETL flows so we can pull the data from source systems and process it and create useful metrics for our vendors. So my team is ARA Premium, where we give really important data to the vendors so they can make important business decisions. I am not in AWS, so I'm like a user who's using the AWS and the Spark and Shark on our services here. So before I get into what I've done and how I created a 1,000-node cluster, I'll let you know what EMR is. So once you know the concept of EMR, it'll be really easier to understand what we have done and how it is so easily scalable. So EMR stands for Elastic MapReduce, and it is really scalable, reliable, and secure. And so I'll give you like introduction on what EMR ties up here. And EMR, we give it as a Hadoop managed offering, which takes the burden of deploying a large cluster away from developers. So when, as a developer, you don't have to waste time in like installing everything, managing it. If anything crashes, EMR takes care of it. And EMR ties up with a lot of services and integrated with a lot of tools. And AWS offers multiple services like S3, Redshift, DynamoDB. We have provided wrappers for everything. So once you set up the cluster, it can talk to everything else there. It is massively parallel. So I'll go to the next slide and how it integrates into the entire Amazon cloud. So if you look at the base here, you have HDFS and Amazon EMR. And you can load data into this from S3, DynamoDB. So let's say you have all your data is sitting in S3. What do? You create a cluster, launch data, load the data into EMR. And it's tightly integrated with other services such as Kinesis, where you have a lot of your, let's say you're doing a log transmission. You can real-time stream the data, process it, send it to EMR. And now this one ties up really well with the other offerings here. So you can use HBase, Flume, Cloudera Spark, and it ties up to other systems in the Hadoop ecosystem like Hive, and it's really good on the Spark here. So what you can do is process data in EMR, access it, and now once you have done all the processing, you can extract this data out of EMR using Scoop to, let's say, RDS system, that's relational databases. And now we have Amazon Redshift. So we have a lot of these components, how all this tie up. There's something called as the AWS data pipeline. So using this, you can actually take the flow of data from RDS, Redshift, everything, and you can load multiple clusters here. And so this gets it. Now let me go into the major Amazon EMR concepts. So when you launch a cluster, what things you see there? So there are three things main. There's a master node, there's a core node, and there's a task nodes. I will go one by one into each. So let's start with the core nodes, okay? So core nodes run task trackers and data nodes. Core nodes are very similar to something called as traditional Hadoop slave nodes. They can process data with mappers and reducers. And here core nodes store data with HDFS. And when you, let's say, you're running a cluster with 10 nodes. And when you scale it, you can add more core nodes to it, and it increases your HDFS storage there. Next one is, and the only problem here is you cannot remove core nodes because since you're using HDFS, removing any data nodes from it causes HDFS corruption. And next is task nodes. Task nodes is something like when you have enough space and you want more computation, more memory. Like in the case of Spark and Shark here, what you do is you add the task nodes. It gives you a lot of CPU, a lot of memory. And the next is you can add, let's say you're processing some data and now you need more computing resources. What you do, add task nodes. After all your computation is done, you can release them, scale down your cluster. That's, let's say during a traffic time, you're getting a lot of surge in traffic. You can easily scale it there, bring it down after it's done. Okay, and now how all these things tie up to Spark on the EMR. So EMR has this really nice concept of called bootstrapping, which I really love it. So what bootstrapping does is it has the ability to install additional packages or software on all the EMR nodes. It is simple scripting, and the script is stored in S3. So what happens during is when you're launching a cluster, the script is called, and on every node or instance which is created, this set of procedures, whatever you write in your S3 file, gets executed. And let's say during your processing, error happens and instance crashes or your node has gone failure. AWS EMR takes care of it, and when a new node comes back, this bootstrap action is called on it. And so whatever packages, whatever you're installing on it, the new node, everything has it. And using this bootstrap action in Amazon, we install the EMR, Spark on EMR, and right now we have an online documentation where we say it supports 0.8.1, and right now we are working on upgrading to 1.0 version there. And why Spark on EMR? The reason, you can deploy small and large clusters on your needs in minutes. So let's say you want to test out before you actually push into production. You create a small cluster, 3-4 nodes. It comes up in minutes. It's pretty simple to launch a cluster. I'll go to that in the coming slides. And EMR manages everything for you, handles the failure. It's integrated with other AWS services, Redshift, Data Pipeline, CloudWatch. CloudWatch is something cool, and where you want to monitor how the cluster is performing, how's the JVM space, and CPU, memory, anything on that. And let's say you create alarms on it. If the usage of the CPU goes above certain %, it can send emails to you, it can send an SMS notification, and it's really tightly integrated with S3. So when you launch a cluster, there's something really cool called as all the logs what your cluster is generating, it is shipped to your S3 bucket. And that S3 bucket you can specify when you launch the cluster. And next, how do you scale the Spark on EMR? Initially, you launch your Spark cluster with a set of core nodes, a master node, and using HDFS, you can store data and checkpoint on the RDDs. And here, how the task nodes, let's say you are needing more processing. You have done some computation. You feel that if I have more resources, I'll be able to do it much faster, more memory. It's good on the Spark side. So you can add task nodes, and it gives you more of memory. Let's say initially you had a cluster with just 32 GB of memory, added more task nodes, you got a 256 GB additional memory. And that's really good. You can do all your computation, perform the computation. Once it is done, you can release the nodes. And when you're doing the processing, what happens is you give you the options to actually load the data directly from S3. So you don't have to bring the data from any other sources, put in HDFS, process it, write it back. So it's directly integrated with S3, and you can write it down. You can do the computations on those RDDs. And these are Spark context, text file, and sequence file. You can call these operations to perform them. As I was talking about, you can write these results back to HDFS and S3 using the save as sequence file and save as object file. So here it shows the data from all the thing is written back to S3. Next is when your job is done, you can shut down your task nodes and you're done there. Now, how do you launch this Elastic Spark on Amazon EMR? So this thing I've covered here, you have a set of core nodes, you add scaling on so auto scale the Spark based on your needs. We have the concept of auto scaling there. So when you need more instances, you can scale it. And when you need Elastic Spark here. So it depends on your job to job. Now, if you need more memory, you scale it. And is your job CPU bounded or memory intensive? Then you need Spark. Spark is required there. And when you can actually add in more nodes. And since Spark uses a lot of CPU and memory, it's good to, when increase your resources, you can add task nodes. Once it is done, remove them. And Spark needs a lot of memory, and it's really good. And based on your memory usages, you can say, oh, I want this type of core instance, I want this type of task node. So you have option to select what type of instance you need. So now I'll go directly into how do you launch a 1,000 node cluster. So you need two simple things here, very easy. And you need one AWS account, and second is you need a Amazon EMR CLI. It's a command line interface you can download directly from the amazon.com site. You'll have the documentation listed on, it's pretty simple to install. And the simple command on launching the cluster. So what I'm doing here is, first I have Elastic MapReduce. I'm creating the cluster with mode alive, so it always stays on. The name of the cluster, what I need, I'm calling it Spark Shark cluster, and I'm calling a bootstrap action, the one I referred to, and this is referencing to a shell script file, which is called install Spark Shark in S3 bucket. Next, I give a name to this bootstrap action, so it's easier for me. And what type of instances I'm calling. I'm using M1 X large instances for my operation, and using 1,000 nodes on it. And this entire, once I click on this and done, the entire cluster comes up in 15 to 20 minutes. Smooth, no waiting. Let's go for coffee and come back, you have the cluster ready. Next is, now you have the cluster ready, and let's say after that you need, I think I need more space. What you do, you can add task nodes, because you already decide, oh, this much memory, this much HDFS is okay for me. And using this Amazon EMR CLI operations, you can add instance. So you say add instance group to a task, instance count, how many instances you need, and what type of instance you require. And how will you know your cluster is ready? So when you go to your console page or use the EMR CLI, your cluster will be listed in the waiting state. That means it's ready. So I have a snapshot of what it shows. So here it says I have one master M1 X large running and 999 core nodes. And see, if you see the lapse time, it says 20 minutes. So when I launched it, it took 20 minutes for it to go into running state. So it's pretty cool there. When when it's reached waiting state, it means it has installed Spark for you, it has installed Shark for you, everything is up and running. And there's something cool here in this. There's a Lynx interface. It's where you can go and see what you have, how much of HDFS space is there. When I saw this, I was like, wow, so much, 1.6 petabytes of storage there. I was like, I should take a snapshot of this. So I have it here. And there is something called as, because some people don't like this, I don't know, command line. We have a web interface, you use your SOX proxy, and you can see your web interfaces, and there is a Spark interface you can refer. It runs by default on port 8080. So I have now the cluster ready. What do I do with it? So what I have done is I have loaded this cluster with Wikipedia data. So this contains early traffic statistics, and it is 4.5 terabytes in size and contains 104 billion records. I had all this data stored in Amazon S3, and the S3 location is there. Let me tell you how this data is structured, how it is. So it has, the file name is page counts and some date and this and everything is zipped. And it's period from December 2007 to February 2014. Everything is tab separated file. So it has file structures. You have the project code, that's, let's say, English. Then page name, what is the name of the Wikipedia page? How many times this particular page was seen in that on that day. That is the number of page views there. And bytes is the size of the page in bytes there. So here is how the sample data set looks. So you have English, Barack Obama, and page views, number of bytes. So take a look at this is how the data is there. So what I have done is I took this data, loaded from S3 to EMR, and processed it using Shark and Spark. I'm a data engineer, so I like writing SQLs, and I have an option. I can use Shark or Spark. I chose Shark and Spark. So most of the queries, what you see here, I have written in Shark. So this is how the table structure looks like. So it's external table, which is referencing to your S3 file, and this is this project code string. I'll not go. And then you have alter table, because it's a high base thing. You actually add partitions to it, and you refer to it. So in this location, in this folder, this is where your partition data is stored, and have added the partitions for till 2014. So after I loaded all this data, the entire loading took around 1 hour for this to load the data from S3 into the 1000 node EMR cluster. So I ran the three queries. The first query which I ran was for top 10 page views in January 2014. And this one took only 26 seconds, and it was scanning a data of 250 GB. It was super fast there. And next I ran, okay, let me try something else. So I ran another query, which one is for top 10 page views overall in the entire cluster. That scans 45 terabytes, 4.5 terabytes, sorry, and 45 seconds. That was like, wow, super fast. The third query which I went for was number of pages in each project codes. So the query is pretty simple, and this took only 48 seconds and scans the entire data set. That's 104 billion records. It was really fast there. And once I had all this data, I was like, yes, best thing is I'll show you the actual cluster which is running here. So I will go to this. Yep. So this is the UI which shows the cluster here, and I have the Spark one which shows user space and it's running here. And the application Spark, I can show it on the AWS console. So it shows here, I have the cluster up and running with the waiting state. This is here. You have the options for monitoring, steps, and the steps, the bootstrap actions you had. And here you can see those 100, oops, that's too big. Okay, I'll go back to the slide here. Yep. And so now I have the cluster up and ready. I was able to do all kind of processing on it, and very fast, pretty quick, in seconds. That was super thing. And next, now I'll go on to how entire thing, what we have done, is tying up to Spark Streaming and Amazon Kinesis. So Amazon Kinesis gives you certain operations just like Kafka, but it is a managed service. So you don't have to worry about the operations instance. You have to create everything. It has simple functions like create stream, which creates a new data stream within the Kinesis service. Put record, adds a new record to a Kinesis stream. Describe stream, and get next record, merge shard, split shard, and delete a stream. So using these options, you can actually send data in real time to your Kinesis. So how this looks like, this, instead of telling me, it's good to visualize here. So I have let's say you have your programs which is generating log files, and you have where you stream all this data. We call it as a producer. It is streaming data to something called as a shard. And each shard has a read capacity and write capacity. And if you need more capacity on this, you can add more shards to it. And once all this is in Kinesis here, there is something you need to consume this data. So there are workers. So currently there's something called EC2 instances. You can write workers on those. And this thing ties up really well on the Spark side here, because Spark supports Spark streaming, and you can process all the data in real time. We have all this documentation, how you can launch a cluster, how you can write a Spark program, and a Kinesis program to actually use the Spark streaming there. And everything is listed in the bit.ly/sparkemr URL. That's it. Cool. Any questions? Good. Yep.
What is the startup time for a specific job? So like 45 seconds that you were scanning through the 4.5 terabytes of data. Is that including startup time? Like with Hadoop, usually there's a couple of minutes.
Yeah, so I use Shark here to actually, so what I did was I logged into the Shark console, wrote the query, kicked it off. The total time from when I entered till the output was there, that is 45 seconds there. Yeah.
Is there a risk of losing data if you're using the Spot instances? Like, is there a way to guarantee that the data is on core nodes if you're using RDB?
Yeah, Spark has if instance crashes and it comes back, there is a data duplication. So even if it crashes, your system is still consistent there. You can read data.
How do you
Right.
ensure that the data duplicates to nodes that are stable versus Spot instances?
So you can say when you're creating your cache table, you can say disk and memory or memory 2, which creates two copies of it. And let's say one instance is crashed, and when the new one comes up, then EMR takes care of it and installs Spark and Shark on the node, and when it comes back, it's added back to the cluster. Yeah.
How long did it take you to load the S3 data into the cluster?
It took me around 45 minutes to 1 hour.
40 minutes from now.
Yeah.
4.5 terabytes.
Yeah, exactly.
So EMR supports YARN or basis framework?
I'm not the AWS person, so maybe you can check on the AWS site for the documentation, or I can come to a booth for the more information on that. Cool, great, thank you.